Everyone, so we're going to talk about osteocalcin today. So it is such a large subject that I can't really do it in one video. First of all, it'll take me 6 hours, and I don't think anybody wants to do that, to watch that video. So what I'm going to do is I'm going to give you the big points, right, as to what osteocalcin does, why it is so important to know about it, how it relates to lactate, the sympathetic nervous system, the excitatory system, right? Energy spent toward the outside, acute stress, all that stuff. And I'm going to explain a little bit the overall points. What I think I'll do later on is I'll take each point and go through a Juliens Corner podcast about it, because I'm guessing each point requires a good 10-15 minutes of explanation on it. And then I'll add it to the course, right? The course that I'm talking about is What is Anxiety, where I'm going to have all my parts about lactate, about osteocalcin, about glutamate, and about noradrenaline all in one place. So I don't know if I'm going to call it What is Anxiety, but it'll be that group, right, where I can go into the cornerstones of the excitatory system, really. Because we need that physiological basis to understand the observation side of things, right? So today, it's going to be osteocalcin. So as you can tell, it does a lot, right? And so I'm going to explain how that works. So first of all, when I write it like this, I do not want you to think this is a deterministic universe, right? Everything is a feedback loop. What do I mean by that? If you read it like this, that means the hierarchy, amygdala, center of fear, creates an acute stress response, okay? And then from there, you get glutamate. From glutamate, that goes to the osteoblasts inside the bone. You get production of osteocalcin. So first things first. Right, but that brings a question. What tells the fifth hierarchy that there is a danger that requires an acute stress response from? Right, and guess what? A signaling, an antenna for that is going to be partly the bone. So as you can tell, it's never that simple. If you read, because I'm going to post a lot of studies on this course so that you can always refer to the things and keeping it in one place, you're going to see that it starts with the amygdala. Someone has to tell the amygdala that something is happening. So it's never that simple. Everything is a feedback loop, right? Don't take it as a 1, 2, 3, because otherwise you'll be tempted to think all I got to do is inject osteocalcin and everything is fine. It doesn't work like that. It's not that simple. Anyway, so fifth hierarchy, amygdala, that's going to relate to that glutamate video that you can see, into the acute stress response, which is what interests us, and then it produces osteocalcin. So first of all, what is osteocalcin? Osteocalcin is what is called a peptide hormone, right? It's a protein that is being produced inside the bone. Technically, it's called the osteoblast, which is a part of the bone that is going to produce that peptide hormone. It is produced once the glutamate comes there, which is an excitatory neurotransmitter. Glutamate gets in there and creates the release of osteocalcin, a peptide hormone, right? So first of all, very interesting point about that. That means that the bone is an endocrine organ. So what does that mean, endocrine organ? Endocrine means that through the action of a hormone, I create a reaction away from the place the hormone was created. That's the definition of an endocrine organ. So you can tell right away that then bones are not just your structure. They're not there just to hold you upright. Bones do far more than we understood up to not that long ago, right? And one of the main things is that. So osteocalcin, why does it matter so much? So we look at the acute stress response, and most people think adrenaline, right? If you get scared, you go like this, heart rate goes up, you think adrenaline. And actually, that's not true. We saw on, a lot of the study has been done on mice, but on people as well. We saw either on mice because we knocked out the adrenaline gland, or on people that had accidents and didn't have any, that even without the adrenaline gland, even without any what is called a glucocorticoid, if you don't know what that is, don't worry about it. Even without the catecholamines, don't know what it is, don't worry about it. That without the adrenal gland, so without adrenaline, we still had an acute stress response equal to people with adrenaline gland. So with or without adrenaline gland, it did not change the acute stress response markers, which is high blood pressure, heart rate, all that stuff, right? That we see, for example, in high intensity exercise, right? It made no difference. The only difference we saw is that the osteocalcin was about double the amount on people that had a proper acute stress response without adrenaline glands. So that means that the fundamental basis of an acute stress response is osteocalcin, not adrenaline, not the glucocorticoids. So that's a huge difference because we've been going on the assumption that adrenaline and then all those catecholamines are the fundamental building block of the acute stress response. It changes a lot of things. I can't go into all of it right now, but trust me, it changes a lot of things. So osteocalcin is actually the building block that matters a lot. So what we're going to see is that there is a direct correlation, not necessarily causation, but correlation between osteocalcin and the sympathetic nervous system. Actually, what we're going to see is that osteocalcin is an integrated part of the excitatory system that I talk about in the glutamate video. So once we have osteocalcin at pumps, what do we see? I guess I'll take it like one at a time. But again, like all those are videos of their own, right? We're going to come with glucose homeostasis. So that's a big one. We saw that there's a correlation between the levels of osteocalcin and the levels of glucose and insulin sensitivity in the blood. So literally, we saw a correlation between the levels of osteocalcin and pre-diabetic or diabetic mice, right? It was that big of a relationship. Low osteocalcin meant diabetes, right? Because it's in charge of the glucose homeostasis, how much blood glucose there is. So we saw two things out of it. We saw that if the osteocalcin levels are high, we see lower blood glucose, and then we see a resistance to diabetes, we see a resistance to all that stuff, we see a resistance to being fat. So mice with high level of osteocalcin were resistant to fat gain. And that's going to come in play right here. I'll explain why. But if you remember the melanocortin vagus axis, I was explaining that the sympathetic is in charge of burning the fat, but the parasympathetic side, the vagus nerve, is in charge of creating fat, right? And so we saw that with increase of osteocalcin, we saw glucose homeostasis. So we see resistance to high levels of glucose in the blood. We see also resistance to the formation of fat. So the mice with high osteocalcin are leaner even with the same amount of food given. Pretty important, right? We see an increase of energy expenditure in those mice. So what does that mean? That means the sympathetic is kicking up. That also means the parasympathetic is being kicked down, which we're going to see here. That matters for something else. So that's a pretty big one. We see that in a high level of osteocalcin, we see a lowering of the symptoms of anxiety and depression. Yep, that's right. So now, you have to understand what that means, anxiety and depression, because that was tested on mice. Right, so what is anxiety for a mouse? That means that they put it in a cage with a big light and usually shadows there. So mice do not like to go into brightly lit, large, non-cover areas because that means predators can catch them. So how long does it take for a mouse to get out of its house to go either get food or something like this or explore the cage that is wide open and brightly lit? That's how they determine anxiety. The longer it takes, the more anxious the mouse is. I know it's a weird, and some of you are going to say stupid way of looking at anxiety, but that's actually the same way we measure it in humans, believe it or not. So, right, welcome to science. Depression, I love that one. The test for depression is you take a mouse, you hang it by the tail, and you see how long it moves, right? The one that takes the longest to stop moving is the one that is less depressed. That's literally how we measure depression. Again, you're going to think it's a weird test. This is the same test we're doing on humans in a way. And this is how we test whether those antidepressant drugs are effective or not. We test it first on mice like that. Anyway, another test, love that one too, is we put a mouse in water, on water and we see how long it stops moving, right? So the length of time before it just starts floating and just stops debating. That length of time decides whether the mouse is depressed or not. Anyway, so what it means is when they have higher levels of osteocalcin, they get out of their cage faster and they fight longer. That's really what that means by anxiety and depression. By the way, out of the cave faster and fight longer, yeah, sounds good to me. So that means anxiety has incapacity of taking action. and depression of incapacity of bringing the fight. Just saying, we're going somewhere. So, what did we see? High levels of osteocalcin. That was fascinating. That one is definitely a video I'm doing on Juliens Corner. Promoted spatial learning and memory. So what it does is that osteocalcin was promoting the sympathetic nervous system innervation in the brain, not necessarily in peripheral organs, but it did promote the sympathetic nervous system into the brain. So nervous system, by that I mean innervation. We don't need to go that far. But it promotes the sympathetic in the brain. So why does that relate to spatial learning and memory? Because that's how you fight. Right? In order to be better at fighting, you need memory because you need to remember who the enemies are, strategy, all that stuff, and spatial learning because it teaches you to move better. How do you think you learn to fight? What do you think muscle memory is? Spatial learning, right? Not spatial learning, spatial. Spatial, not special, not special, spatial. Whatever the fuck you say it in English, that's the one, right? So that matters. This one was a big one because we saw, so how did they find out? Again, I'll put the studies. You need to read that one. It's really good. They had mice that do not produce osteocalcin, right? Genetically, they just took it out. And the progenitor, so the kids of the mice, were dumb. They could not memorize well, and they had very poor spatial learning. Spatial. Oh, I like it. Spatial learning. Right. So what did they do? They took the mice, and once they were pregnant, they put the osteocalcin into the blood of the mouse, the pregnant mouse. And the kids of the mouse, the progenitor, ended up with better memory and better spatial learning. So the symptoms of dumbness went away, right? Just by doing injections of osteocalcin into the pregnant mouse, not into the babies, into the pregnant mouse. Right, and so there's a big one right there. So what is very interesting into this is that we saw also that osteocalcin, in a way, reversed the effects of aging. Because if you see the two main effects of aging is loss of cognition, memory and spatial learning, and muscle tone, the capacity of muscle to contract and keep the muscle mass and everything. Both those things are being reversed, not stopped, reversed with osteocalcin, which means it's a hormone that is capable of reversing symptoms of aging. Again, not stopping aging, reversing aging. So there's a big one for you. Osteocalcin, high level, promotes the production of testosterone directly, which means, long story short, they have those cells that produce testosterone, right, in the male testicles and everything. They put the osteocalcin through those cells, and they saw right away the production of testosterone. So that means that higher level of osteocalcin increases the production of testosterone. Right, so for all you bodybuilders out there, that's all I'm saying. What we saw also is an increased male fertility. There's that's epigenetics, but there's a very specific trigger for the production, toward fertility, so spermatozoid and everything that was triggered by osteocalcin. That's another video I need to make. One of the very interesting effects is the high osteocalcin has a direct effect on the parasympathetic nervous system. So it seems to stop it. Osteocalcin crosses the blood-brain barrier. Right, that's very important. That's why it has a direct effect onto the brain here, because it's capable of crossing the blood-brain barrier. Not always obvious, but in that case, for that particular peptide hormone, it goes right through and goes toward the neurons associated with the parasympathetic nervous system. Namely, it stops the production of acetylcholine. Acetylcholine is a neurotransmitter of the parasympathetic nervous system. It stops the production and reuptake. So that's a major one. So what does it do? It takes the brakes off the sympathetic nervous system. So by taking the brakes off, it increases the acute stress response. So it doesn't just promote toward the sympathetic in the brain and stuff like that. It also removes the brakes by taking off the parasympathetic nervous system, that can act as a brake to the sympathetic. It takes away acetylcholine, the major neurotransmitter. So that means that PNS inhibition will have an effect on fat production as well. So that's where all that stuff starts to go into a loop and you start to go, ooh, right. By the way, an issue there, acetylcholine is what gives you coordination. That's a massive oversimplification, but you get the idea. This is really what we need for coordination. So that means that too high of a level of osteocalcin will continuously put you into an inhibition of the parasympathetic, which means you can never chill the fuck out. And on top of it, it will start to impact coordination. So for example, you are at a major competition, you start to freak out, right? That's why you can't move anymore. That's why once you get punched really hard, for example, you see people, they start to get angry really fast because you can't maintain focus. And then you start to lose your coordination and you see boxers just swinging left and right. That's why freaking out too much means that you cannot stay in control of your movements. Interesting, isn't it? Osteocalcin, we saw GABA inhibition. That's normal because GABA is, in the excitatory system, is the opposite of glutamate. Glutamate is toward excitatory and GABA is on the other side. I'm not going to say it's an inhibition, anyway, it inhibits GABA. That's a video I have to do. You don't even need to know what GABA is, but it's very important because we're going to see that it relates to the parasympathetic inhibition as well. It's the opposite of the excitatory system, really. So you can tell osteocalcin is a major part of the excitatory system. There's no way around it. The osteocalcin, once you pump, promotes the synthesis of monoamine neurotransmitter. What does that mean? That means it promotes the synthesis of dopamine, serotonin, noradrenaline, which is the neurotransmitter of the sympathetic nervous system. It goes on and on and on like that. So you can tell the importance of osteocalcin. It's a cornerstone of the excitatory system, and it's produced by the bones. So that tells you the importance of the bones in that whole equation. It is not as simple as saying all you need to do is to go through fear in order to produce osteocalcin. Even though that is true, this is very limited in the way of looking at it. It takes way more than that. But that also means that the bones will become an antenna of the excitatory system on the other side. So that doesn't mean that the bones are the only way to create an excitatory response, but it means that an action directly on the bone will create an excitatory response because it's a feedback loop. So that means that a stress onto the bone will create a fifth hierarchy response. So that means that a stress on the bone will likely freak you out, right? And if it's too novel, then that's where fear comes in. Fear just being a gradient of a novelty response that goes straight to the fifth hierarchy that decide whether or not you should bring into consciousness if the need arises, right? So that feedback loop is going to be very, very important. What I wanted to show you was how important it is to produce osteocalcin. Between the response, the insulin response and glucose and testosterone alone, it should tell you that whatever we do training-wise has to impact the bones, that the lesser stressing of the bones will lessen us as human beings. From an intelligence perspective to a fertility hormonal level to being fat and having diabetes. Not the only answer, but one of the main answers to those problems come from this. And that's the acute stress response. So do not think the acute stress response is a bad thing. So that all day, namaste the bear way is the craziest idea out there. Like that idea that we have to push everything toward the parasympathetic side of the system is insane. Actually, that is not true at all. Most of our good stuff comes from the acute stress response. You cannot stay away from it. You should actually seek it out and just understand how to deal with it. The problem is people do not know how to deal with it because they're not introduced to it anymore and therefore want to shy away from it. We should do the exact opposite. We should do toward the acute stress response, we should just learn to deal with it. That's the difference. And as you can tell, osteocalcin is necessary. So, stress the bones.